Alright everyone, welcome back to the day 10 of our daily LeetCode challenge, and today we have got word subsets. So let us try to understand the question here. It is given that the word B is a separate subset of string A if every letter in B occurs in A including multiplicity. So what they mean by this is that a word, let's say A, B, C, will be a subset for the word X, Y, Z, X, Z, Y, A, B, C, C, A. This word right here, ABC, will be a subset of this word. It is because A appears 2 times here, 3 times, and the word B appears 1 time, and the word C appears 2 times. So so there are 2 conditions that needs to be met. First is that each and every character in the given word, let's say X, which is this one, each and every character in this word X should be present in this word Y. It should be present. That's first condition. And the second condition is that the frequency of each of these characters in the word X should either be matched or should be basically less than equal to combination we are seeing in the frequencies. So we can have A appearing 2 more times here as well. It would still be a subset, because the frequency of A here is 3 and it's 3 here. But if it had been just 2, or let's say there's like 4 A's present here, then in that case it wouldn't be true, because it's not less than equal to. What I'm trying to say is that the bigger word, or the word Y, for it to be a subset, like for the word X to be a subset of a word Y, the Y should at least have the frequency or more than that, basically I'm saying. So 2 conditions have to be met. Each of these characters should be present, and the second condition is that the frequencies should be less than or equal to. So this frequency thing is important here, and that's what the meaning of subset is. Now let us take the example of word 1 and the words 2, which is our first example. So they have provided us with a list, 2 lists they will be giving us, words 1 and words 2, and we need to find all those words in the words 1 list, which is list 1, all those words which are universal. Now what do they mean by the word universal? If a word in this list will be universal, if this word, for this word, each and every word present in this list is a subset of this word. Like if say we have 10 words here, all these 10 words, if they are a subset of a given word here, in then that case that word will be universal. So we need to find all those words which are universal and then return those words from this list of words 1. So let's take the first example. We have 5 words they have provided us with: Amazon and Apple, Facebook, Google, and LeetCode. Now these are the list of words they have provided us in the first list, and we need to find, and the words 2 that they have provided us is E and O. So now what our task is to find all those words in this list 1 from Apple, Amazon, Apple, Facebook, Google, LeetCode, like all such words which are universal, meaning which of these words are actually subset, like for which of these words, each of these words in this list is a subset of that word. So let's take the case of Amazon. As I said, we have 2 conditions to be met. First is the characters should be present and the frequency should be greater than or equal to. So in the case of Amazon, right, in the case of Amazon, we have E appearing 1 time in this case and 1 time in the let's take the example of Amazon here. We have E and O. Now the condition is that each of the words in this list that they have provided us should be a subset for the word which we are checking here. So let's take the case of Amazon. Is E a subset for Amazon? We see that E is present. It's not present, so E is not present. So again, since it should satisfy all the words, so we will not even consider this. Now let's go to Apple. Is E present in Apple? Yes, it is present. But is an O present in Apple? No. If it's present, then we also have to make sure that the frequency should be a greater than equal to case, right? We have 1 here and 1 here, so it's fine. Now let's take the example of Facebook. We have E here once and O here once. So is E a subset? It is. We have frequency matching, words matching, it's fine. E is a subset. For about O is a subset. We see O is present and the frequencies are also greater than equal to case matching. So in the case of Facebook, we do have those things matching. So Facebook becomes universal. So let's keep it separate here. Facebook. Now let's take a look at Google. We have two O's, and as I said, the word should be present and the frequency should be greater than equal to. Is E present in Google? It is, and the frequencies is 1, so greater than equal to case met, so it satisfies for E. Is O present in Google? Yes, it is. It appears 2 in fact, so 2 is again greater than equal to 1, so we are fine with this also. So Google also comes as one of the result. We'll type Google here as well. Now let's take the example of leetcode. We have 3 E's, 1, 2, 3, and frequencies is greater than equal to, and E is also present. So first word is matching the condition. Let's talk about O. We have a single O here and a single O here, greater than equal to, still match. So leetcode is also a valid answer here, keeping it separate. So in the end we are getting Facebook, leetcode, and Google as our final answer, and that's what they are also returning us in this case. Let's take the example of the second case. We have got in the second case we have got the words as Amazon, Apple, Facebook, Google, and the words 2 as L and E. So it's basically almost the same. List 1 is same, and they have provided us the words 2 as, instead of E and O we need to check for L and E. So let's do that. Let's check for L and E in this case. L and E. So in the case of first word Amazon doesn't have an L, so we don't even go further and check for other words. Amazon is out of question. Apple has one L. Apple does have an L in it here, and the frequencies is also greater than or equal to, meaning the frequency of L in Apple should actually be either greater than or equal to the frequency of L in this word. It is so. So yeah, this condition is matching. So Apple is one of the answers. So now comes E. Do we have E here? Right? Yes, we do have, and the frequency is also greater than or equal to condition is also matching. So we'll have E as well. So this is matching for both the words. So Apple is an answer. Now let's go to Facebook. Facebook doesn't have an L, so this is out of question. Let's go to Google. Yeah, we have one L here, frequency is greater than or equal to. We have an E, greater than or equal to condition met. So Google is also a valid answer. Let's talk about leetcode. We see one L right here, it's fine, and we have 3 E's, greater than or equal to conditions met. So it's fine. Leetcode is also a valid answer. So for our final answer is becomes Apple, Google, and leetcode. Do we have that as our answer? It's true. Apple, Google, and leetcode is what we are finding here. Now, what would be the naive solution of doing this? The naive solution of solving this question would be going through each word, getting the count of it, and then again checking is what we're gonna do. But then again, if we do it poorly, it's gonna go a TLE. But if you notice, they have already provided us with the fact that the length of the words is 10, is in the range of 1 to 10. So what I'm trying to say is that the Python, like the function of counting, can be used here, because since the length is not that long, so the count method, which is usually a O of n depending on how long the length of the word is, it would be feasible here because the length won't cross 10. So this will almost be kind of like a constant type, you can say, because the length is in a given range 1 to 10, so it won't be that large compared to the set that they have given us. That's a one. And the other thing that I want you to notice is that, let's say now that we have understood the question, right, let's see what we are missing here. What they have already provided us with is a list of words here. Now they have only given us single letters here, but this could be more than that as well, because it's given that the words of both words 1 and words 2 can go up till 10 lengths, right? So let's take this example, right? Instead of E and O, let's try to compare it with this word right here. Let's say I have a word love list like this: E, O, and another word as O and O. We'll run the same example. We're gonna run the same example for this list now, E, O, and double O. Now Amazon, right? We had Amazon at the first case. doesn't have an E, so we don't want go for further. Let's go for apple. Apple does have an E, it's fine. It doesn't, so this word is satisfying. But for this word, right, O, this word O is only appearing once, so this is satisfying here. But then the last word has two O's. Now since this has two O's, it won't be satisfying Amazon specifically, because again the greater than equal to condition is not met. The frequency of O should either be greater than equal to 2 or more. Now did you see, like, let's say that we had a word which kind of satisfied for a word which had two O's. Wouldn't it satisfy for the word which had single O? We are seeing it like this, right? Let's say that Amazon spelling was like this, AMAZOON. If for some case Amazon spelling was like this, in that case double O would have been satisfied, and if further down the line a single O would have come, that would have also been satisfied, right? Because the greater than equal to character, greater than equal to condition would have been met. So what I'm trying to say is that if somehow we knew what is the maximum frequency of a letter that is present for each of these words in this list, then it would be easier for us to find for the remaining as well. Like let's say I knew that the maximum frequency of a character here instead of 1 is 3, then we know that if in the following words 3 condition is met, then we can say that it's going to match for words which are shorter and which don't have that much letter in this. Like it would match for words which had like 1 or 2 O's as well. You could say that, like, if it solves for the maximum occurrence, then it's going to solve for the any occurrence which is less than that as well. We have to kind of use this trick right here to optimize our solution for this question. So now let's see how we can do that. Now we know that we have to basically check that which words here are actually universal, right? So that means they should be subset for all these words here. Now since we know the definition of subset, right, we know there's a definition of subset. The definition of subset is the word should be there and the frequency should be greater than equal to. Now let me take another example to explain you what I mean by that. How we can use this frequency trick that I just mentioned to optimize the solution. I'll take one more example and then we'll code this up. This will kind of clear it to you guys what I'm trying to say. Alright, so let's say that we have a bunch of words, right? This is our words to list. Now it could be from the range of 1 to 10, right, as I said. Now we'll take some bigger examples. Let's say I have one word as ABA, the other word as OOC, and the other word as EE, and the other word as XXY. Now this is our words to list. We need to find which of the words in words 1 are universal. So this means that for a word, right, for it to be universal, it should be a all these words right here should be a subset of this bigger word. This is what I mean. All these words right here, ABA, OOC, EE, XXY, should be a subset of this word here. We haven't seen that word yet, but let's try to understand if they would have existed a word, what should be the minimum number of characters it should have. Now if we take a look in this all these words, right, is there a way by which we can find what all characters are actually present in this words? We can find that. We can use Python and then understand what characters are actually present in this word. Like I'm trying to reverse the problem here. I'm trying to find like what could be the possible word for which all these words could be a subset, right? Now you already know the definition of subset. The definition of subset is the word should be present, so that word should definitely have a, that word should definitely have a B, that should definitely have a C, a E, a O, an X and Y. How can we find that? We can quickly do a quick run on all these words and get the characters that are present. So that will be A, B, C, E, O, X and Y. So this is our first step. Like the word that is gonna be a subset for all these words is 100% gonna carry all these characters. It's gonna carry an A, it's gonna carry a B, C, E, O and X and Y. All these characters are gonna be there 100%. Now comes the frequency, right? Now comes the frequency. Now for this word ABA to be a subset of that word, we already got done with the first part. The word should be there, and the second thing is that the frequency should either be 2 or greater than that. So the frequency of A right now for this word, what we are seeing is that frequency should be 2 or more than that. So let's just keep it as 2 here. Like minimum what we need is a 2. So far that's what we have seen, right? Then comes a B. We see that, alright, B is how many times appearing this particular word is appearing 1, so minimum we need 1. Now comes A again. Again we saw it's 2 is needed for this word, so we have kept it as at 2. Now comes O. O is 2 times here, so we need a minimum of 2 at least in that word which will be forming here. We need at least a 2 of O or more than that. Then comes C. It's 1 here, so we need a minimum of 1 C here. Then comes E. We see it has 2 E's here, so minimum of 2 E's is gonna be required for sure, either 2 or more than that. Then comes an X. We see 2, then it's safe to say that we need at least 2 X's or more than that. Then comes Y. So we need at least 1 Y or more than that. So are you guys seeing a pattern here? What we are seeing here is what is the minimum number of characters we definitely need, and that is nothing but the maximum of what is present for each of these characters throughout. Let's say further down the line we had another word. We had another word which was something like this. It had 4 A's, 3 B's and 2 C. Is it exceeding 10? It should not exceed 10 though. 3, 6 and then 7. Yeah, and we can have one more 8. So now, so far with this word appearing these many times, these letters appearing these many times, if we had a word something like that, all of these words would be satisfying. All of them would be a subset. But how about this one? Now we are seeing that it has 4. Now since we already had 2, the minimum is 2 required here, but since we now have a 4, so we have to say that alright, now we need at least 4 or more. Otherwise it won't satisfy for this word. For this word right here to be a subset, for this word right here to be universal, all these words have to be a subset of this word right here. So since this we just encountered a 4 here, this needs to be 4 or more than that. So now we update it. So if you see, right, we can create a hash map. We can create a hash map of all the letters that we have, starting from A, B, C all the way to Z, and then we iterate, and then we can quickly do a count. And since the length will be less than or equal to 10, so the count won't be that expensive. We can quickly do and every time we encounter a word, we just quickly go through all these characters, do a count. This is again constant, 26. It won't be more than that. So we go through all these characters. For each of these words, we go through the character, each of the characters 26 times, and then we see if it's we see the count, right? So far, what is the count? So far the count is 2. Alright, so 2 is needed for sure. For A, 2 is needed. For B, 1 is needed, and that's it. Then we come to O, and we see, alright, for O, 2 is needed. For C, 1 is needed. I'm gonna write it here. And then further we go down to E, then E, 2 is needed. Then further down the line we'll see this word right here. For then we'll see that, alright, it needs 4. So we're gonna update the count of A from 2 to 4. Then we'll be like, alright, we need more than 2, so it's gonna be 4. In the end, after we iterate all these words and do the count, we'll be having a hash map which will basically consist of all the characters that they are formed of. So if all the characters that it's formed of is, it has words like A, it has a character B, it has character C, it has character E, it has character O, X and Y. In the end, we'll be having a hash map which will have the maximum amount of characters that it should have. Like this will be like a kind of a base case, like a condition that will be satisfying all the for which if that condition is met, any word which meets that condition will be a subset. So what I'm trying to say is that condition should be, the words should be there, and the minimum frequency should be either 4 or more. If it's less than 4, it might satisfy for this word, but it won't satisfy for this word. That is why we need 4 or more of A's, and for B's it's gonna be a maximum maximum occurrence at the time is 3, so it should be 3 or more. If it's less than 3, it might satisfy this, but it won't satisfy this one right here. Let's say further down the line we encounter another word which had 5 B's. then we'll again update this b count to 5, because the maximum should be satisfied. The maximum is satisfied, all the other words will also be satisfied. That's what I'm trying to say. For C, again the maximum which has occurred at a time is 1, so it's going to be 1. For O it's 2, for X it's 2, and for Y it's 1. So this is what our kind of condition will be met. So once we have this hash map right here, right, we can then iterate each and every word from the other list and quickly do a check. If the word is there, each of those words in the other list, which would be from this one, words 1, we have to just check if the character is there, and if the character is there, the count of that character in that word should be at least greater than or equal to 4 right here, 3 right here, for each of these words. Now this is how the problem is getting solved, and this approach kind of makes it a O of n plus 1, n plus m. I'll explain it to you how. Let's try to see the code part and then see how it's working. Now let's quickly code this up and see how it actually is. So as I said, first what we need is a character of all the words that are forming these words right here. And we need a set of characters, like the set of characters which are forming all the words in the second list. How can we do that? We can do that in a single line in Python. So I'll define a list 1. This list will carry all the characters which are actually present in all the words forming in the words 2 list. It's only single character here, but in some examples it could be more than that, as we discussed here. So to do that, first what we need to do is we need to join all these words in this list and form a big word which is basically containing all these characters. So this join operation is making those. I've already discussed what this join operation is. This join operation right here is basically creating us the bigger word. Now since we have this, let me quickly convert this back again to a list. Now this list will have all the characters in this mega word, which will basically look something like this. For let's say if we join all these words together, it will become a big word like A, B, A, double O, C, E, E, X, X, Y, 4 times A, 3 times B, and 1 times C. This big word is gonna form. The final list will look like something like this, but we don't need duplicates, so let me just convert it to a set. Once we convert it to a set back again, this is going to be a unique set which has all the characters, but since this is a list, so we'll have to convert it back to a list. Now this list right here, if I print it to you, is going to be the list of all the characters that are actually making all the words in the words 2 list. You'll see. So ENO, ONE, case 2 it's LNE, case 3 it's this. Let me try one more test case, which is this one right here. Let's say that we had a list 2 as like something like this. It could be anything, but it should be less than 10. It's gonna tell me all the unique characters that are actually appearing. So the first test case, this is what we are getting, all the unique characters that are actually appearing in this list. Now since we have that, we need to create a hash map. Initially we will be mapping all these letters to a 0 frequency, as a 0 frequency. So to create that hash map, let's quickly use list comprehensions right here. So we'll have list 1 and then an array of size list 1, and all of its elements will be 0. This zip function basically is zipping these two lists. List 1 is this list that we saw here, and this 0. Imagine there's another list getting created here which has zeros, as many zeros as these characters here, and then we are zipping them together. So once that zipping is done, it's going to create a hash map for us. If we print it, initially it will all be 0. All these characters having 0 frequency is initially. As you can see, all these characters, this basically means that the words 2, these are the characters that are forming, and they all have 0 frequencies in them. Now since we have that, we can now quickly do a count for each of these words. For word in words 2, we are running the count. Now we know that each of these word in words 2 is going to be formed by either by only of these characters. Now we need a count of those characters, like for each word here and for each of these characters here, what is the maximum count for a character. We need to keep updating that. As we saw here, we need to keep updating. In the first case, the frequency of A is going to be 2, but later down the line the frequency will be updated to 4. We need that so that we can find the universal word. So right, we need for each char, right, if the word dot count is greater than hash map, initially in the first one it's going to be 0, but later it's going to keep updating. So here, right, after I run this and print this hash map now, it's going to basically give us the hash map that I was talking about. In this case, if you run it, right, it's going to update to, let's say that here, right, if we see we have 2 A's all the way up till here, it's still 2 A's, but let's say I add another character which had 5 A's and 1 C, say 5 C's, then it's going to update that later. Now if you run it, yeah, the size got exceeded, no issues. Let me reduce some of that. So as you can see, right, if you go to A, it got updated to 5. Later down the line, it found a word which had 5 A's in it, so it updated it to that. Now if we go through the word one, right, we'll need a word which had at least 5 characters in it or more. Will definitely be a for that word, this becomes a subset. Now since this became a subset, all the other words which had less than A will also be a subset. That's what I'm trying to say. So this is this is why this maintaining the count and updating it with the maximum count becomes important. So now since we have that, right, we can quickly run a for loop on all these words right here on the words one list. As I said, what is the first condition that needs to be matched? First condition is the character should be there. And the second condition is the frequency in words of that character should be greater than or equal to. Those are the two conditions that we checked. So you basically have to check it for all these characters. All these characters should be present in that word, and the frequency should also be greater than or equal to. So there are two conditions. First, if the character is there and the count of this character in this word should be greater than or equal to the hash map value that we have. If that's the case, then we don't need to worry about that word. We'll go to the we'll just let that pass, because there are multiple other characters also that we need to check it for, right? So just do a pass here, like it is satisfying for one character. Else, let's say it doesn't pass for any one character, we'll have to set a flag. This will flag us for that word. So let's say that for a word, right, for a word it passed it for a word, right, let's say for this example, for a word it passed through all the characters in this hash map, and yeah, it did find an A, it was there, it did find a B, it was there, and then we should basically stop. Alright, so now we are basically iterating all the words in this one. Now what this hash map has provided us with, all the letters that are actually going to be there. So for a word in word to be a subset, right, we need the first condition that we saw is that all the characters should be there. So we are assuming it's already there, because then only it is going to be universal. So that's why we're going to run a for loop on all the characters in the hash map. The basic condition is that if the count of that word is greater than or equal to the hash map count, then we are basically good, we'll pass. Else we'll set this flag to 1 and then break it, because this particular word is not getting satisfied. So if a word is not getting satisfied for any of the character, then we shouldn't even bother for it, because it should satisfy for all the characters and all the characters, right? Otherwise, like for in the case of Amazon, we didn't even find an E, right? That is why the count of this character in the hash map will be, in this word will be 0. So we'll have to break the loop, and in the end, if the flag remains 0, it means this word didn't pass the test. In that case, we're gonna just append that to a resultant list that we're gonna define here. Words gets added, and then in the end we're just gonna return this res. So if you run this right now, see, it's passing all the test cases that we see, even the ones that we discussed as the example as well. If you try to submit it, yeah, so this is the solution, and the reason why this is a O(n) of m is because the hash map size will never exceed more than 26, right? So if you see this for loop, right, words 2 length and words 1 length are basically the defining ones. The hash map size is going to be not more than 26, because there are 26 characters in the alphabet, and the count is, again, since this length of this is almost 10, so this is also almost, you can say, constant. So overall, the final time complexity for this one is going to be big O of n plus m, where n will be the length of the words 1 and m will be the length of words 2. So words 2 and words 1 are the only longer list which we are iterating, and since hash map size is almost constant here, the words length is less than 10, so this is also acting almost like a constant, so the count method won't take that much time. So the only time consuming parts in this entire algorithm would basically be the iterating of the words 2 and words 1. That is why if you see, right, our submission right here is beating almost 97 of the test case, 97 of the other submissions. So this code is pretty efficient. Alright guys, that was it for today. If you guys liked, please do consider subscribing, and I'll see you guys tomorrow.